Good morning. This is Wednesday, March 2nd. For KAP, here's the word up on the board. It's just this one equation that you're solving for n. Please pause and play when you're ready. All right. So hopefully last night with your homework you got enough practice to be like, okay, you always ask yourself what's happening, how do I undo it? What's happening, how do I undo it? Okay. On this problem, what do we see, class? We see. What operation do we see, class? We see multiplication. We undo it with division, okay? Split it, divide. I always use a fraction bar because, again, if I were to write divide by 5.2 on either side, technically I could write it in two different orders. I don't like that. Divide by negative 5.2. Negative 5.2. On the left side, those two would cancel out. I'm left with M. Over here, my answer sign-wise, signs are the same. Okay, let's try that one more time. Signs are the same. Great. No. All right, and then we have to divide. A few of y'all might have freaked out because, oh my gosh, we got another division with decimals in a hot second. Which one goes where? 5.2 top in, bottom out, 5.2 goes from this. Okay. 55.12 and 5.2. When I divide with decimals, it's okay to have decimals on the inside, but on the outside, that's where it gets weird. So in order to get rid of that decimal, I'm going to move it one space to the right, whatever I do on the outside. Do y'all remember like what allows me to do that? Like what mathematically am I doing for using times 10 because it's just moving that thing over. Okay, moving it over one. Go ahead and bring it up so you don't forget. So now I have 52. Does 52 go into 5? Yes. Does 52 go into 5? No. Does it go into 55? Yes. 1. Okay, that's going to leave me with 3. Bring down the 1. Does it go into 31? No. So we put a 0. Okay. Then bring down the 2. What do y'all think? 6. Okay, 6 times. 6 times 2 is 12. Carry the 1. 6 or 5 times 6 plus 1 is 31. Okay, so n is equal to 10.6. What's the mathematical way of saying that? 10 to 10. Try to make sure y'all got it all. Okay, any questions on that? Okay, if you had to like check the realisticness, if you did like 10 something times negative 5 something, I should get negative 50 something, right? Okay, is it a reasonable answer? Yes, it is. All right, homework questions. Again, I'm glad that I saw quite a few people marking questions. Devani, which one? Number 6. Sorry. Number 6, okay? P over negative 4, I'm rewriting it just a little bit bigger. Negative 4 is equal to negative 12. So class, what operation do we see? Division, we undo it with multiplication. I'm going to multiply both sides by how much? Negative 4. Negative 4. Negative 4. These two cancel out, and left with P is equal to signs are, nope. They're the same. They're both negative, so signs are the same. Positive's the game, and it's 48. Okay, if you plug that in, 48 divided by 4 would give me 12, and then the signs are different, so it would be negative. Okay. Other questions? Payment. 7. Okay, negative 35q is equal to 5. Negative 35q is equal to 5. Just looking ahead on this, one, I already know my answer is going to be negative because it is a positive. Another thing, if I'm multiplying a number by 35 and getting 5, is that q value going to be a really big number or a really small number? Small, because I'm starting with 35 and it's going to get smaller, right? Like, other than the negatives, like technically a negative smaller, I'm talking about like the size of the number, the value of that number is going to get smaller. So in my head, I'm already thinking it's probably some sort of decimal or fraction. Okay, but still going back to those questions we ask ourselves every single time, what operation do we see happening with our variable? Multiplication, we undo it with division. So I'm going to divide both sides, and I always use a fraction bar. I'm going to divide both sides by negative 35. Okay, this cancels out. I'm left with Q is equal to that. Now you have a few options because again, division is always a fraction. I could just technically simplify that division problem like it was a fraction. I could divide both of those numbers by 5, and I would end up with negative 1, 7. Sevens are one of those nasty decimals. You'll learn that over time. But if you actually turn it into a decimal, again, if you went from 5 and 35 and you divided, I understand that's probably what most of y'all did. 35 is not going to 5, so I do decimal and a 0. 35 goes into 50. Once 35, you're left with 15. Add a 0, it's going to go in 3 times. So that's going to give me 15. That's going to give me 10. 105. So that's going to give me 45. And this is going to go on for a while. Sevens, they don't look like they're repeating, but they do eventually repeat, but it's after like 8 digits. So that's when I'm like, ew, leave it as fractions. Okay, that's when fractions are our friends because definitely sometimes that's okay to have fractions. Okay, are you good with that? Okay. And does that make sense with what we were talking about? Like it's a fraction number where it's a really small decimal and it's making that smaller. Okay, I think a lot of us get thrown off because we're used to integers. Saki? Number 8. 5, 6K. Again, I'm just rewriting these. Is equal to 1, 6. Class, whenever I see a fraction, I should be needing to get rid of it. I just need to do what? What with its reciprocal? Multiply by the reciprocal. Which fraction am I using the reciprocal of? There's 2 fractions of 5, 6. Because I want to get rid of this guy, so I'm going to multiply it by the reciprocal. Whatever I do to one side, I do to the other. Okay, cancels out. I'm left with K is equal to 1 times 6. 6 times 5, 30. Okay, I can simplify that. They're both divisible by 6. They're also divisible by 3 and 2. And if it's 2 and 3, therefore it's 6. But that would give you 1/5. That's the same thing as 0.2. 12 on the back side. Grocery store is having a 2 for the price of 1 sale for several items. The cost of the items is shown in the table. Davion bought 2 boxes of cereal and 2 loaves of bread. He also paid 39 cents in tax. The equation that can be used to determine how much money he gave the cashier. Determine how much money he, in dollars, gave the cashier who received $13.12. Okay? So using this equation, so that's a funky looking equation. I'm going to admit I've never seen one of those in this class before in my lifetime. Yes, of course I have, but we have not looked at one of those together. So order of operations. Let's go back to that old thing. What does order of operations tell me to do first? Parentheses. So that's what they did. It's hard to see, but they added all of those values first to get $6.88. So I'm left with X minus $6.88 is equal to 13.12. Do we understand that first step? Okay, then it's an equation that we learned how to solve. I want to get X by itself. I see what operation? I see subtraction. I undo it with addition. So they added, you can't see it, but they added to both sides, and then they got $20 as the spring. Okay. Last questions? Yes. 14, and then I'll do this. At the end of the soccer season, 4 families decided to buy the coach a gift certificate to sporting goods store. Each family contributes $35 towards the gift certificate. Write and solve the division equation to find out how much gift there was. Did you write a different equation and you just didn't understand how to make it a division problem? Okay, so they haven't, they don't know how much total money is being contributed, right? That is our unknown. So X is going to be our unknown value. But they do know that each of the 4 families, like that total amount. So, okay, honestly, I might not have started with my equation like this. What I might have said is that, okay, if I know that each of the 4 families is contributing $35, I need to figure out that amount. okay? I understand in your head that's probably where you're at. But hopefully you've noticed, especially on that first page, whenever we write equations, sorry, on this first page, the operation is always happening to x. In the equation that I just wrote, the operation isn't happening to x, it's on its own. So you have to think, you always have answer choices like on a test, but you have to say, okay, how could I work this to have it be a division problem, okay? Because that's a multiplication problem right there. To make it a division problem, I could say, well, okay, I have X amount and I split it, I divide it amongst the 4 families, and each family, because we know when we divide, we only take one of those chunks, each family is carrying $35, okay? And then technically that's how you solve it, okay? Again, with multiple choice, with tests and quizzes, there's going to be answer options, and you just have to choose which one, so it's going to be a lot easier, okay? And then Andrew, 11. Keisho has $45 to spend in a pizza shop for a pizza party. The table shows the cost of each size of pizza. He bought 4 smalls and 1 large. Which addition equation can best be used to determine how much more money he still has to spend? Okay, so 4 small, that's going to be a total of $20, and then the 1 large, it's 10. So there's a total of $30 spent right there. Okay, so again, you might have written it like Sword Power did with that one we just talked about. You might have thought of it as 45 minus 30, and that gives you like X amount left to spend. But you want the operation to be happening to X. So instead, you could think, okay, well, it's going to be the cost of those pieces that I bought plus however much that I used to spend, and those two together should equal 45. But you see how it works in this. Okay, because it's sort of like solving it, like, oh, I need to get this on the other side, so I add 30, I add 30. Okay, so I have 45 is equal to X plus 30. It seems weird, but the operation's always happening here. Gucci? Okay. Yes? Okay. All right, so we're going to go ahead and hop into today's notes. It is going to be modeling. We're going to, instead of just having one step equations where all you have to do is one operation to get X by itself, that was what like last night was on, and now we are going to have 2-step operation. We are going to model it, and yes, you are going to model, and you are going to draw the models, and you're going to smile about it every single step of the way because we love models. They help us, and they love us. Yay. But then we'll do the math side of it as well. So, remember our goals when we're solving equations is that we always want to get X by itself. We want to isolate X. We use inverse operations to undo things. So the inverse operation of subtraction is, and the inverse of multiplication is, they all undo each other. Okay, whatever you do to one side of the equal sign, must do to the other. We always want to find the value of just 1x. 2x means x is in, all that good stuff. Okay, so let's start with just the model. I'm given the equation 2x minus 5 is equal to 9. Again, they said that you could also think of that as 2x plus negative 5, because adding the opposite. Are we good with rewriting? Okay. In the model, we have 2 x's. Are we good with that? And then 5 negatives on one side. On the other side, we have those 9 counters. We good so far? Okay. Now, my goal, again, is I want to get all this extra stuff off. I only want the x by itself. So first, do you think I want to get rid of the x's or the black counters? Black counters. And how have we learned to get rid of those black counters? Add the opposite. So we add 5 positives. Y'all good with that? Now we're on balance. Whatever I do to one side, do to the other side. 1, 2, 3, 4, 5. Okay, do I have any 0 pairs anywhere on my board that I can take the color away? Yes. Okay, over here on this left side, those 0 pairs can go away. And now I'm left with 2x on one side, and I'm left with, how much on this other side? 14. Okay, 2 x's is equal to 14, but I don't want 2 x's. I want to split those evenly. I want to find the value of just 1 x. So I have to figure out, okay, if I split them evenly, each x is going to get how many? 7. Okay, so I could say this is going to get 7 of these counters goes with this x. This one's going to get, I did too much. You know what I mean? Circle above 7. Okay. That one gets 7. Okay, did they have equal amounts? Class, do they have equal amounts? Yes, x is going to equal 7. Okay, let's look at the math beside that. Okay, I have my equation written, split it right down the middle. Okay, what was our first step mathematically? Do we want to get rid of the x's or the constants? We want to get rid of those constants first. So if I have -5 to get rid of that, I'm going to do add 5 on both sides. Plus 5, plus 5. Okay, the negative and positive 5s, those were 0 pairs. So I'm left with 2x is equal to 14. What operation is happening to x? Undo it with division. Divide both sides by 2. X is equal to 7. Okay, we haven't talked about this yet, but it's going to be quick and easy. How to graph your solutions to equations. Here's a graph. I'm going to put some numbers on it. One of those numbers is going to be 7, 6, 7, 8. Okay, y'all good with that? Okay, I haven't said which of those numbers is my answer. Which number is my answer? So I'm going to plot a dot on 7. Wow. That's the hardest part. Are y'all good? Yeah. Did y'all make it through that? Okay, I'll let you practice more. X is equal to 7. Now, how could I check without a doubt and know that my answer is right without any decide on the ticket or quiz or text? How can I know that X is equal to 7? Plug it in. 2 times 7 gives me 14 minus 5 is, wow. Okay, always check it. Y'all want to try that next one? Ready, set, go. Draw the model. Show the model. Do the math. Do the math. All right, tell me what to do. 4x plus 2. Oops. 4x plus 2 is equal to -6. Tell me what to draw, Tanner. Because. 4 boxes with x. Thank you. 1, 2, 3, 4.
Then 2 positives.
2 positives.
Then on the other side, 6 negatives.
6 negatives. 1, 2, 3, 4, 5, 6. Anthony, what should I do first to help get 1x by itself?
That's negatives.
How many negatives?
2.
2 negatives. Because, guys, those make, what are they called? 0 pairs. But now I'm unbalanced. Anthony, what do I need to do? Other side. Add another 2 zeros. Okay? Those cancel out. Bye-bye. Michael, what should I do next?
So we want. Where are we?
We have 4 x's on one side and -8 on the other side. I don't want the value of 4 x's, so what do I need to do?
We want to join the 2 together.
I'm sorry?
So,
I think you said it right. I just didn't hear you.
join the x and the other side.
Uh-huh. How many counters is going to go to each x? 2. Okay? We want to split, okay, because we're going to be dividing. We're going to split those counters evenly with each x. Each x is going to get 2 of those counters, but those 2 counters are negative, so x is equal to -2. Did y'all get that? Awesome job. So let's look at the math, because again, this is ultimately where we're going to go. So mathematically, do I want to get rid of the x's first or the constants? Constants. So how do I get rid of +2? -2 or take away 2, however you want to think about it. Okay, I'm left with 4x. This right here, when it's a negative number minus another number, sometimes y'all tend to struggle, and I definitely did. If you're having trouble like figuring out negatives minus negatives, if it helps you to write it sideways and then adding the opposite, if you need to write it opposite side, I totally get that. I know that took me an adjustment when I was a kid. I was like, and honestly, still as an adult, I like sometimes vertically, I have trouble doing negatives, and so horizontally don't actually want it's just a character trait. Yes, ma'am.
I said because when you multiply by the same sign.
Yes. It could be that I think that honestly could be it, is that I'm thinking it's multiplication, but it's subtraction. Class, when I do -6 minus 2, that gives me -8. What's still happening to x is multiplication, so I need to divide both sides. X is equal to -2. Okay, on this graph, what do I need to put? I need to at least have -2. I like the number on each side. What's the number that goes on this side? -3. I think someone said -9, sure. Over here, -1. Remember, negatives are flipped. Which one's my answer? -2. Honestly, I'm gonna do one more with you. I'm gonna go out of order because I think there's a weird one. 5. Let's go with 5. I think 5 is another weird one. Okay, let's do it together. Y'all tell me what's the model. Okay. Oh my God, where's the x? It's on the other side. Ah! Are we done? Okay. Okay. So tell me what's the model. On this left side, I need.
4x.
No. What is on the left side? -1. Okay. On the other side, for the 3. 3 positives. 1, 2, 3. Minus 4x. How do I do minus 4x? -4x. So 1, 2, 3, 1. -x. -x. Gucci? Okay, give y'all a second. Okay, just because the x's are on the other side, I'm still going to do the same thing. I want to get x by itself. What am I going to kick off first? The constant. So how do I get rid of those constants? 0 pairs. How many do I need to add? 3, because I want to get the x's, so I need to take off these guys. That's why I'm asking, because it's a weird one. So I need 3 what times? 3 negatives. If I add 3 negatives on this side, 3 negatives on the other side. Wow. Okay, get rid of any clutter, any 0 pairs. There go. Okay, now I'm left with -4x's and negative counters. Okay, so there's a couple things I need to do. First of all, what do you think? I need to make them positive for one thing, but I also need to split them, right? Okay, let's start with splitting them because that's what we've done before. Each of those x's is going to get how many counters? 1 counter. Okay, so y'all can go ahead and circle that. Okay, but I'm not writing x equals quite yet. Right now, I have -1 is equal to a -x. Do I want a -x? No, I want positive x. So there's a couple ways you can think of it. -x is the what of positive x? It's the opposite. So what's the opposite of -1? 1. Okay, that's one way to think about it. I'll show you on this other side more specifically, but I could also think of it like this. Okay, -1 is equal to -x. What coefficient, what number could I put in front of that x that wouldn't change the value? 1. Okay, so now you can maybe see, oh, it's x times -1. If I want to get x by itself, I'm going to divide by -1, divide by -1. This cancels out, I'm left with x. -1 divided by -1 is positive 1. That's the math way to think about it. Okay, let's go look at the math side. Okay, split it at the equal sign. Okay, this is going to be the weird one. What did we do first? We got rid of the constants, right? We got rid of whatever we add or subtract. That number 3 right there, as it is, to get rid of that 3, that number 3 is positive or negative, as is. It's positive because it takes on the sign in front of it. There's nothing there, so it's naturally positive. So to get rid of that 3, I need to -3. A lot of people get uncomfortable because they're like, but that's not the opposite of this, okay? Just give it a second. Okay, that matches our model too because we started with 3 and we added -3, -3. This cancels out, okay? -1 minus 3 gives me -4. Now on this other side, you have to be careful. What am I going to bring down? What is still left? It's a -4x. That's when that subtraction sort of turns into a negative. I've learned it's still sort of a -4x. Okay, you got to be careful. That it's a little spicy. To get x by itself now, I need to do what operation? Divide them both by,
4,
nope,
-4.
-4. Those cancel out, I'm left with x, and I'm left with 1. Now, Ms. Lytle, this one, I really don't know if I feel confident on my answer. I really don't know if x equals 1 works out. How can I check? Plug it in, okay? If I did -1 is equal to 3 minus 4 times 1. Order of operations tells me to do multiplication first, so -1 is equal to 3 minus 4. 3 minus 4 is, works out. Okay? That one's a weird one, but I did it with y'all. Hannah? Yep. That first step, okay? Again, I know that y'all see subtraction and you're like, oh, you tell me opposite is to do addition. That's when the model really helps because the green over here in the model is what I started with. I started with 3 positive counters and then taking away -4s. To get rid of 3 positive counters, I do 3 negatives, aka subtracting 3. Okay, it's because that subtraction sign really goes with the term after it. If you remember when we combined like terms like when we did like 4 minus 3x, we took the sign in front of it. Okay, that's why. Okay, yes, Taki.
So, sorry.
You're good.
Over there, -1 equals 3.
Yep.
So that one, I have a question.
Yep.
About that.
Yep.
So you said that you take the sign that's in front, right?
Yep.
So then why didn't you take the sign for the -4 times 1, right?
In a way, I did. Okay, we said that this was 4, right? But I bring down that subtraction sign, so it is. If you want to say take on that sign, that's a -4 times a +1 is -4. In a way, if you want to think of it like that. Okay. Okay, that was a little spicy. What I want you to do, take a few minutes to do the rest of these problems. We'll come back and check. Ready to go. Okay, here we go with answers. On that front page, we had done number 3. If you notice, to get rid of these negatives, you should have added 5 positives, and you did the same thing on this side. Okay, these canceled out to make 3, just the 3x, and I think a lot of y'all got stuck because on this other side, you also have 0 pairs. Okay, so whenever you have negatives and positives, you cancel out both sides. You get 3x is equal to -6, and then you split them and all that stuff. On number 3, you should get x is equal to -2. On the back, number 4, x should equal 4. 6, we get x is equal to -3. And 7, x is equal to -1. Okay? For your homework, as we highlighted so nicely, yes, you are going to model tomorrow when I check for homework. If there are no models, you get what? Okay. Please, it doesn't take too long. I think most of y'all have already started your homework. Keep in mind on Friday, so day after tomorrow, we will have a quiz over this kind of stuff. You got it. You're gonna